Okay, good evening, everyone. Let's just review what we had last week. So, in the second part, we reviewed general concepts of blockchain, how and talk about the trust problem, how each blockchain resolve that issue, and we also talk about different parts of Bitcoin ecosystem, including mining, hash function, characteristics of hash function. Also talk about different sections of a block, and we said that the previous block hash is the one input to the next block. So if somebody either should never hack a hash or hack all the hashes, because whenever you hack one of the block's hash, is automatically input for the next block, so it would ruin the next block hash, and also you need to hack the next one. So basically, attacking or hacking blockchain is difficult because you need to do a very difficult problem for all the blocks that are existed in the system. We talk about maker theory concept. I also talk about one of its applications, finding issues when you want to save large files. Let's talk about public and private key and how you can sign and verify a message. That message doesn't need to be a text message, could be everything. And we also talk about other like Coinbase, mining, extraction, orphan blocks, verification, possible attacks. As a couple of assignments, so let's go. Also, at the end of the class, we had one experiment. Actually, we had two experiments. So we had a demo of blockchain. So you learn how to install Node.js, how to install Git, how to clone a project on your system, and you run that demo blockchain. And also we had second demo, which was more sophisticated and talks about some transactions, how to do mining and what happens if you do change some of the transactions that you have. Also, as I mentioned last class, if you want to do these practices for the next run, you don't have to clone and install from scratch. You just need to do two steps. Just go to the file that you download, that is for downloading for cloning from GitHub, and also npm stuff. Then you can run those demos. Alternatively, the easiest way, you just go to this website, and those demos are hosted on this links. Any question about the previous concepts that we had in last class? Also, if you check your model, you have 4 assignments. At least for first assignment, most of you submitted, but for assignment 2, 3, 4, is you have quite a bit of time. But the due date passed for the first and second exam, but still, assignments. But still, some of you haven't submitted yet. Please do the submission as a part of your credit for this course. Oh. Let's just exit this one. Let me show your model. Yeah. So the due date for the second assignment is today, and also you have third and fourth assignment coming up. Please just follow the deadlines and just submit your assignments accordingly. Also, you have a TA, which I posted his information today. So his office hours is on Thursday. You can either stop by his office or just ask an appointment or just do a Zoom meeting, and hopefully he could resolve some of your issues. Okay, so having said that, so for today, we spend another time, but this time we do blockchain design. So we do it through coding, and more specifically Python coding. Have you guys ever had any coding experience like Python, except for Dr. Han? Just she's a reference for except for her. Everybody else, have you ever had coding experiment with Python or so whatever other tools like what can I say, Tableau, Power BI, or maybe Excel? Yes, SQL. Yeah, I don't want to talk about scripting software. Something like some software that has GUI and like you just drag and drop. So for the who had Python R, so have you ever worked with NIME or IBM data mining or something like that? So, but I think most of you work with Excel at least. So if you do, so if you want to do, let's say, if you want to find the mean of some numbers in Python, you should write the command. But in Excel, maybe if you just select those numbers, you see their mean. So working with those softwares might be much easier, but generally speaking, there is some limitation. First of all, you have less flexibility. If you want to be a developer in blockchain, you need to do scripting. And also, usually those tools like Excel, they have limited functionality. And even if you are hardcore programmers or let's say hardcore developers, every day new updates coming out, new packages, new codes. Usually it takes much more time to some tools like, such as NIME or Excel adopt those functionalities or updates, which sometimes they never adopt them. So again, it might be very hard what I'm talking about. So, but generally speaking, if you want to be a developer, you need to learn programming, scripting in general. It's not possible to use intermediate tools. Like last class, I showed you a demo. So you did a blockchain demo using somebody else, let's say software. But that demo has a lot of limitation. You cannot do everything. You are limited to that person's development. But if you want to have more flexibility, if you want to do more advanced commands, usually you cannot just use somebody else's software. You need to do your own coding. Okay, so since today, since our class has some wide variety of skills in terms of program, like somebody maybe never had any coding experience, somebody might have has spent after 30 years of coding. So they are not, we have a wide variety of skills, programming skills. So still, we will have some experiment today, but no worries if you never had Python experience before. I won't evaluate. I never evaluate based on your Python skills. Anyway, so at least do a couple of things for today. First, install Python. As you see, I'm installing the last available version of Python is 3.10.4. But when you Google Python on your system, it doesn't need to be latest, exactly my version. Just Google, download Python. Maybe first link. So still the latest version is 2.10. Oh, you cannot see my. Okay. So I just Googled download Python. I picked the first link. and this yellow rectangle, download Python. It might take a little bit. So after downloading, you are more than welcome just to click next, use defaults. But I usually install for all the users. So what I do, usually I customize and install Python for all the users. But you don't have to do that. You can just click next, and install. I wait 5 to 10 minutes so everyone can install Python. Nathan, which IDE you ever have used for Python? Have you ever used it? Jupyter, maybe? Spider? Oh, no. Is it like standard for undergrad here?
No, we use
Jupyter?
Jupyter, yeah. And then I just started using that for it's easier to figure stuff on that.
I see.
It like came with Anaconda.
Mm.
So
So for the people who never work with development environments such as Jupyter Notebook, Spider, or Pycharm, so you don't have to have that. So you can just use Python from scratch. But usually those development environments for ease of use, especially if you are a new programmer, you are prone to have so many typos and maybe not matching different parts of your codes. So having said that, usually people recommend to use development environments. Usually for early learners, it's Jupyter, but Spider is a good one. But in my point of view, the best one is Pycharm. Spider also is a good one. Jupyter, all of them are good, but usually if you want to be a developer, Pycharm might be the best one. But again, if you are interested to use the other development environment, you are more than welcome. Today, I teach you some of Pycharm. Basically, I already did Python code, so you don't have to do that. So in the next slide, I'm installing Pycharm, which is the development environment. As you see, after the installation, you have to reboot your system. So I give you quite a bit of time for doing that. Again, similar to Python, just Google download Pycharm. The website JetBrains, just go to the jetbrains.com. So there is two versions. One is professional, the second is community. Basically, almost for most of developers, you have these types of versions. One is held by the company, the second by a community. So what does community means? So if you have any issues with the software, you cannot call company. So you have to Google it to say, okay, I got this error, what can I do? But versus if you have the professional version, usually there is a customer support that you can reach. Usually early learners use community because they usually don't have that much of big issues. But if you are, let's say, working in a company, then making softwares, many times they use the professional versions because for them time is important and they want to just call someone to resolve their issues. Again, as a student, you can register and download even the professional version, but it's not the one that you want to do today. So just pick your operating system and download community version. It might take a little bit of time to be downloaded here, but after downloading, just click on the Pycharm and do next. The only thing that might be good for you is just maybe you can add the folder to the task. You don't have to, but if you do this option, that's even better. But again, for Pycharm, just download, install, and then reboot your system. So again, for today, I won't teach you how to do blockchain programming. I already have codes. I just want to show you to do some operations over blockchain using Python code. So again, no worries if you never have seen any Python code. I think it might take about 10 minutes because the file is about 400 megabytes, then you have installed, then reboot. So just please take your time, download Pycharm, and just install on your system. For instance, everybody has a development environment at this time. So if you never work with the packages, basically there are a bunch of functions and classes that some developer developed like during the years. So whenever you want to do your own programming, you don't have to do everything from scratch. You can use other people's packages and just develop on top of the codes that they provided through their packages. So similarly, for today, for this project, you need to have some packages to be able to be efficiently programmed. But I already provided those codes and installed the packages within my Python environment, and I provided the environment here. So if you go over Moodle, go to Part 3, Materials, and crypto_project.zip. Please just download this zip file and extract it somewhere. So I extracted on my document folder. So this is my crypto project. You can bring this environment to any developer that you would like, maybe Spider or Jupyter, but I'm not a Spider or Jupyter. I used them before, but not too much. I'm mostly on Pycharm. So I teach you how to bring this codes and environment into your Pycharm environment. So inside your Pycharm, just click File, New Project. So you need to specify two sections. First, location of the projects is crypto project that I identified. So I browse on my system, go to crypto_proj. So for the Python interpreter, I can either use the system interpreter or just use the environment that I provided. If you use the environment that I provided for you, you don't have to install the packages. So what should you do? Just click on previously configured interpreter. Click on browse. Again, click browse. So under crypto_proj, just go to crypto_env, then script, then select python.exe. So crypto project, crypto_env, script, and python.exe. So if you do use this interpreter, you don't have to install the packages. You can just do as it is. For your own IDE, Python development environment, just search how to bring an environment into your development environment. I also put on your slides. So two sections important. First, the location of the project that you extracted the file. Second, address of python.exe underline, which is under your project folder, under environment folder. I give you like 3 or 4 minutes, so you guys can download, extract, and also bring that project into your Pycharm environment. After identifying these 2 addresses, just click on create. And it might ask you if do you trust this project. Please trust, it's not a virus. Also, might ask you some like basic default questions. Just please say yes to all of them.
What's the name of the interpreter file on the scripts?
Python.exe. Exe. Yes. Okay, let me see. So the only thing I'm still developing, Patches to your own Python.
And the other matrices and Python load. Yeah. So
I did this environment through Windows for the Mac users, might give some error. Basically, it doesn't recognize your interpreter. What can you do for Pycharm? So here, lower right side, there is a section for your interpreter. So as you see, for me, it's crypto underline env. This is from the environment, but it may not work for you. Just change it. So if you have another Python.exe, just select here. I come to your computer, but on top of that, you need to install a package. So after, if you already have installed Python on Mac, you would see two interpreters. Just select the other one. Also for the packages, just after on Python, select interpreter settings, then click on this plus sign. Here you need to tag cryptography. So cryptography, this package, and you have to install it. So if I show you again, this is the package that you need to install. So on signature basics, so I Ctrl+C, Python 3.2 interpreter setting. And you have to install this package. So I come for Mac users to see if I can help. So we don't have typing, so so I have done fine here. So here, browse location. You get the issue that it's perfect. Okay. So just have to finish. So based on what I've seen from your friend's computer, for some people, either Windows or Mac, sometimes it didn't like the interpreter that I picked. So if you got the issue and you see it gives you some error, just click on this lower right. It said Python 3.10 crypto EMV. This is the Python interpreter that I sent over Moodle, just click on this one, select interpreter setting. And from this menu, you just select the other environment, other Python that have on your system. Which for your friend, I did that. So we just try to find another interpreter that works for their own Pycharm. So again, interpreter setting or add interpreter. So with add interpreter, you can search on your system. For example, look, my interpreter is in C, program 5, Python 3.10, Python exe. So for you, might be a folder on your system. So anyway, if you have any issue with the Python that I sent through the environment, lower right, click, add interpreter, and just browse to the location on your system that you already installed Python. If you do that, the only thing that you have to do, select your interpreter, click this in plus sign, and type the packages that you need to do. You need to have, for example, for today, we need to have cryptograph. You need to select this one and install the package from here. So there is another package that you don't have to have it for today, but just as a practice, I think if you're a Panda programmer, you already heard of, so if you're a Python programmer, you probably heard of Panda. It's a very common Python package. Again, as a practice, install the Panda package here. Lower right, select your interpreter. Click interpreter setting. Click this plus sign. Search for Panda. After selecting the Panda, click on install package. Now, if I close it, I have Panda package here. So you don't have it. You don't have to have it for today, but this is just again another practice how to install a package in Python. Okay, let's try to do our first experiment working with encryption. So encryption is not just for cryptocurrency, it's also in general purchases that you do over internet. So what it happens, you have the, I mean, your company has the seller's public key. With the public key, it encrypts your credit card information and send it to the vendor. The vendor could be Amazon.com. So Amazon.com has a private key, which they decrypt the message, and they can find your credit card information, and then they use it for transaction. So if somebody try to get into the communication line through the internet and capture data here, if they don't have the private key, they cannot understand what is going on. So only the person who has private key can decrypt and understand the information. Again, the differences between traditional decryption and encryption and blockchain encryption is, so if you hack one block, you should hack all of them. So there's a lot more security on the system versus here, if you just hack one transaction, you can just steal money and just run away. Maybe the bank eventually catch you, but you don't have to just hack so many other chunk of information. Just one transaction, hacking one transaction is enough. On top of that, we talk about hashing. So also you could hash. You don't have to just do hashing for blockchain. So the verification based on the majority vote. So if more than 51% say a block is valid, everybody accepts. And also we have miners, and basically these miners decide about the verification of transactions and also blocks. So today and tomorrow we are going to learn about them and have some experiments. Okay, I just talked about connection of the blocks, where in the sense that whatever you have in the first color would be hashed and sent to the next one. So in the construction phase, when you want to do this chain, always we calculate the previous block hash with the hash function. So there's a hash function that you apply on the previous block, and you save it as previous hash. So it's how you construct your chain. For example, for this block, the previous hash, this characteristics is a function that you apply in the previous block, and this data goes into the next block. So what happens if somebody just, like previous slide, if somebody just hack one of the blocks? There's a verification phase, which again, you check if the previous hash of this block is equal to calculation of previous hash of the previous block. You do calculations. If somebody changed this block, if somebody hacked this block, when you want to verification, when you calculate the hash, the calculated hash is not equal to the next block's data that is already saved. Maybe I have to do over whiteboard. So okay, when I want to build a chain, I have a function. This function takes input and calculates this value, and I save them my chain. So one time I did calculations, and this is saved somewhere. Let's say there is somebody hacked this information here. I would say Maozin sent 100 BTC to Elon. So if Elon friends hack this block, what happens? When I want to do calculation, then I want to calculate the hash. The new hash won't be equal to the previous hash. Because every time I calculate this hash, and I just checking the hash that I record. If somebody hacked this, you cannot verify this. Again, if you hack this one, you already kept record of this hash in the next block. So when you want to calculation, you check the next hash with the new calculations. It's the reason if you hack one block, you have to hack all the blocks after. Because every time you do this comparison, you compare previous hash that you recorded somewhere with the new calculations. So if you want to put it like a note, just keep in mind this self that previous block hash function parentheses. This is in calculations. Self that previous underline hash is something that you record somewhere. It's previous. Questions so far? Okay, so if there is no question, hopefully all of you could figure out how to in this project and how to set up your interpreter, your Python interpreter, so you would be able to run the code now. Just before going through this code, so every time, I mean, before starting the code, just check these codes are working. So there is two ways. One, you might see a play button. You can just click on it. If you don't see any error, probably the code is working. Or if you don't see the play button, just inside Pycharm, just right click and you can find the play button and just click run. For example, right now I'm checking signatures underline basics 1. Just click run. And it seems it's working, so I could be sure that my interpreter is already in the right position. So let's look at this code. The first part is just importing. Again, I have to oversimplify because some will never work with the Python. So the first part is just importing the packages. So somebody already did some coding. I'm just did import. I just use their own code in my my code, so I don't have to type too many things. So then look at the next function, key generator. As you see, it seems it has some preset argument, but look at the return. Return shows the output of this function. What are the outputs? Private key and public key. If I go a little more in details, look at the inside of key generator. First, it calculates my private key from RSA generator private key function. Again, even for me, maybe it doesn't make too much sense, but this is like RSA that generate private key. Is it the function that somebody already developed? So if you want to go more in details, just please check cryptography package. And that in the package documentation, they give you all the details of these functions. But anyway, from this function, you can see first we calculate private key, then we calculate public key from private key. Look, public key is equal private underline key dot public key. So it just show you that we derive public key from private key. The output of this function is just both of private key and public key. Let's check the signature. So the sign or sign function, it seems it just has two input. First is message. The second is private key. You might remember in the previous class, I showed you that your message could be anything, could be a picture, could be somebody send crypto to someone, or just could be even a poem. But message could be anything. With the private key, you can sign the message. is an electronic signature function. So I put some comments here. So let's say you want to put some comments here, and later on you just read your comments. With the hashtag, you can do that. So look what I do for commenting. On top of def sign message private key, I put hashtag and type the next function calculates, sorry, this function creates a digital signature from private key. With the hashtag, you can just, with your own words, put some comments, so Python won't mess up with other codes. It just, Python considers this as a comment. Okay, the next function is for verification. Look at the inputs. My input is message, the digital signature that I have, and public key. What it does, you put the message there, and it check the signature with the public key, and if it's a valid signature, it just verify as true. We make this transaction, so having sent to BTC to Shein, Nathan sent 10 Bitcoin to Shein. So the sender, the one who actually sent the Bitcoin, should sign this message with their own private key. Hamid and Nathan, both of them have the private. So if they sign here, it would be a minor, less than Nazi. Now Nazi can verify. So let's say he's the miner, he would check this message, would see the two persons who sent the money actually signed this transaction. So from Nazi as a miner, this transaction would be bad. But let's say instead of having who has the private key, let's say Ramona signs with her private key. When the miner, which is mouse, it checks the signature, it will say no. This is not. He cannot verify this message because he's looking for Hamid's signature. He cannot find it. So in point of view, he will say no. This is not a valid transaction. And these two persons, Hamid and Naim, shouldn't release a private key because if people have a private key, they can sign all the messages. Questions? So if you look at this function, what happens? So the verification function is under miner's control. He has the public key. He checks the message with the signature to the public key that he has, and he or she can verify if a message is valid or not. Again, the miner who does verification doesn't need to and shouldn't have the private key, because even let's say Ma'azin as a miner, if he has the private key, he can validate, and at the same time he can just send Bitcoin to his own account. So the miner always have the public key. Okay, so let's look at this line, which might be very common in many Python codes that you ever have seen. Can anyone tell me what does if name equal main means? Yeah. Yes, very correct. Thank you. So what it does, so my code, which is signature underline basics 1, it could be even work as a package. You can import the functions that you see here into another program. If you import it as a package to another program, you cannot run here. You cannot run everything after name equal main. But if you don't use it as a package, if you just use this code for running the commands, it runs whatever you see after name equal main. So many people use it for checking because they define some function top here, and they want to check if this function works. So they just add this line name equal main, and they want to run that code without using as a package to see if those codes and function above are working or not. Okay, so let's look at this code. Okay, first line, I'm just saying using key generator, create a private and public key. PR stands for private, PV stands for PU stands for public. And also with this print function, I'm printing those keys. Let's just run it. So right click, run signature basics 1. This is these two lines. My private key is PR key 1. My public key is PU key 1. So just show you like an address or object identifier. Okay, so I give you a couple of minutes if you want to put comments, then I go to the next slide. Okay, so look at the next line. Here, instead of saying who sent Bitcoin to whom, I just said message equal please come to Worcester. So with the private key one, I can sign the signature and assign it to a signature. So again, in the next line, I'm printing the signature. So my signature key hexadecimal is because this signature is a hexadecimal format. It's not human friendly, but I just printed to just show you here. So here, this is your signature in hexadecimal format. So then look what happens. I'm verifying the message with the signature one that is created with public key one. Do you think if I do this verification, the result would be correct, true or false? So the message was signed with the private key one. Now I want to verify with public key one. Like that message, let's say Hamid sent Bitcoin to Shibu, Hamid signed on his own private key. Now Miles will want to check that message with Hamid's public key. Do you think Miles would accept or would check? Pardon? So you are saying it doesn't verify? Or you say it's verified? Why? So let's look at here. So now I said to Bitcoin Shibu, assign it with my private key. You have my public key. You verify this message? Yes. What happens here? So we have a verification of a message with the signature which is signed by a private key. We use from same key generator, we use this public key. So we do verification. If you look at the result, print, result of the verification is verification result form. And the answer is true. So here I did the if function. So if in front of if is correct, it runs the first line. Otherwise, it runs the second line. Verification result 1 is correct, so it's run the first line. The signature is valid. Please do accordingly. Look at next part. I'm creating a new pair of private and public keys. Also here, we sign a message with the private key. But look at the verification. So we are verifying the same message, which is signed with a private key 2. And now we want to verify the public key 1. Do you think this verification would be true or false? Why? Yes. It's like here. Like instead of having signature, you will make a signature. So now we know that's Look at the last verification. So here again, since verification result is false, it doesn't run the first line. This time it runs the second line. And spam message is disregarded. Let's look at the last verification. So this time, we add in United Kingdom. So the message was, please come to Worcester. As you know, there's 2 Worcesters, one in United Kingdom, another in Massachusetts. So somebody add in United Kingdom after please come to the Worcester. So they changed the message. So look at the verification this time. So I want to verify the new message. It is a hacked message, which signed with the first private key. And now I want to verify with the first public key. So if you look at here, let's say this is the message. You have the signature at the bottom of it. But suddenly, maybe she was trying to put 1 0 here. Bank her payment. So this time, since the hash could be different, when browser wants to check this, verify this message, it cannot verify with the public key. Because if you change even one number, one character, all of the hash could be different. So this time when you do verification, you cannot match this signature with this message, this public. Questions? Again, this is code, a lot of flexibility. In your own time, spare time, maybe you can change a little bit of function, you can change the verification game. So now you have a lot more flexibility in terms of playing with the private public key and do your own experiments. Okay, let's have a break, maybe 15-20 minutes. Then we go to the next part of the class. Okay, we continue discussions. We use some more functions. The first one, we are looking at structure of a blockchain in general. As you know, there's always the first block we call it Genesis block. And here, as you see, we have two branches. One, the 5 blocks, and one, just 2 blocks. Basically, as I said, usually in the Bitcoin blockchain, we wait for TR6 verification. It just means adding TR6 blocks after your block. It just means all of the miners agrees that is the longest chain, and everyone accepts this chain. So the blocks that are not in the main chain would be disregarded, and we just call them orphan blocks. Just means the majority of miners wouldn't verify and won't consider it as inside the main chain. Also, we have another concept which is transaction cryptocurrency. So usually, if someone in the general speaking transaction, we just send everything out. So some basically it doesn't. It's equivalent of if you, let's say you have 10 Bitcoin and you want to spend 8 of them. So it just means you keep 2 Bitcoins in your account and send 8 of them. But the internal transaction of Bitcoin blockchain is different. It just, even if you spend 8 Bitcoins, you spend all of the 10, but you send back 2 Bitcoins to yourself. Might look stupid, but it's how they design Bitcoin blockchain. I explain it later on, but just as a basic at this point, just keep in mind in Bitcoin blockchain, we don't have a remaining of account. On your app, maybe it just shows that in the remaining of your account, you have 2 Bitcoins, but under hood, whenever you want to send something, send out, you send everything out, but some of them would come back to your account or public address. So we have a sender, receiver. You might have multiple sender and multiple receiver in one transaction. Also, somebody need to verify the transaction. Generally speaking, there are miners, but today we just have somebody who is required to verify your transaction. So somebody verifies your sender and receiver. We will have both of them today, but I just wanted to show you the general methodology behind of it. So on your project, please open blockchain underline basic 1.py. As here, I identified 2 classes. The first one, sample class. It's just arbitrary input. So here, I just wanted to just define a sample class that doesn't need that much of thing. It just has 2 inputs. The first input is a sample string, the second one, sample number. So then it takes 1 input and assigns it to sample string, and the representative would be a string of sample string underline sample number. So again, there is no mathematics behind it, that you can make your own class. It's just an arbitrary class. I just want to show you that your input doesn't need to be a message, could be even a class. Okay, so, but this is the actual block. So I define a class of block. So it has 3 sections. First is the data or message. The second is previous hash. The third one is previous block. So it has to, so as you see, data, so if you never worked with the Python, it's really hard to explain, but it just means I inputted transaction data and assign to data. I import the previous block and assign to previous block. So if the previous block is not empty, so means you already have a previous block. You calculate the previous block hash and assign it to previous block. If I show it on the board, so for the genesis block, it's your first block. The first block is not, there's no first block, there's no first. But any block after genesis block, you have previous block, which is the date of previous block assigned to you. Previous hash, which is calculation of hash on the previous block that you assign to this value. Look at the next function. The next function is the hash function. As you see, first it takes the data and previous hash. Here, digest just means the length of your hash function is same, digested to the same length. So it just shows you how these numbers is created. So this number is the basic hash of this block cross previous hash. So this number is just this calculation of these two. And look at the validation. So the validation here is very straightforward. After you assign the previous hash value here, and you are done with the block, you do this. You do this verification. If someone changes the data, a calculation of hash is different from what is said in the next block. So the validation would be false. I'll give it a couple of minutes if in case you want to add some comments. So in the following part, I created the blockchain. As you see, we have a Genesis block. The Genesis block has two arguments. The first argument is the message or the data. The second is previous block. The first block is none, so I put none. Then look at the block one. The block one has its first message. The message is the first block after the Genesis block. The other input is the previous block. So with the Genesis block as the second argument, if you go back here in the block class, it calculates the previous hash and assign it to a variable with the name of previous hash. And look at the block 2. I'm creating block 2 from Genesis block. So if I show in here, these are block 1 and block 2 that is added after Genesis block. I created block 3. So the input here is just a random number, 98765. The parent block is block 2. So as you see, block 3 after block 2. Then I create block 5 after block 1. And here, sorry, I create block 4. As you see, the input is a sample class Satoshi. This is just a random class. So as I said, you might have different inputs. Block 5 is created on top of block 1, and here you have at least like a Bitcoin message. Elon sent 10 Bitcoins to an alien, and block 6, alien sent 5 Bitcoins to pizza shop, and its parent is block 4. This is what you see here. So Genesis block 2, 3, 4, 6. And we have a couple of orphan blocks, so block 1 and block 5. Later on, block 1 and also block 5, these two wouldn't be saved and deleted from transactions. Let me run blockchain basics 1. Here I created 6 blocks. In the next parts of my code, I want to check if they are valid. As you see, I'm doing a for loop inside a list of my block numbers. And every time I want to do the calculation of previous hash and just compare it with the one that I already saved. I didn't do any hacking. I didn't change any information. So anytime that we check is this if condition, it runs the first part because it's always true. Just the reason here, it will print success, hash is good. So you see it did it 6 times for all of my blocks. We'll wait in a couple of minutes if you guys want to add some comments. Now let's say somebody hacked the blockchain, changed some of the blocks. You want to see what happens. For example, here on block 3, data component changed to 110. What it was, block 3 data part was 9876. We changed it to 110. Now, if a miner wants to check previous block 4's previous hash with the new calculations, it gives a false. It gets an error. So the result would be false because right now the previous block data components change. So when you do calculate the hashing here, the hash function is different on the left side. So left side is not equal to right side, which is the recorded previous hash. So since the result would be false, the second line after if or else part would be wrong. So success, the hack is identified. Somebody hacked the blockchain, changed one part of block 3. In the verification phase, when you want to do hash, the new hash won't be equal to the previous hash. So you get a, you can identify that somebody hacked one of the blocks. And same for 2 other parts. So in block 4, data, and inside the data, the sample number changed to 666. So what is after block 4? Block 6, right? So if a part of block 4 is changed here, if you want to calculate the hash of block 6, which is block 4, it won't be equal to the previous hash output that you recorded. So these two won't be equal to each other. So the result would be false, and the second line would be wrong. So success, the block is identified. So somebody hacked the block. Again, my point is, if somebody hack a part of blockchain or one block here, for example, a part of block 4 is hacked, part of block 3 is changed. When you go to the next chain of the blockchain and you want to check what you already recorded as the previous hash and new calculated previous hash, you can just compare these two, and if they change, you can understand the previous block is changed, and you won't verify the previous block. Let me wait a couple of minutes in case you have questions or want to add comments. Then I go to the next code. So inside this code, I put some extra print functions. They are not necessary. I just want to check the progress of my code. For example, look at this part, print block for data sample number and print block for data. The results are here, 1, 2, 3, 4, 5, 6, and Satoshi underline, 1, 2, 3, 4, 6. When somebody hacked the code, again, I wanted to print sample number and data. As you see, now it changed to Satoshi underline, triple underline, 666. It's just something for extra check and for me to see the progress of my code. Okay, the last part of the code that I'm going to review today, I think it's too much for today, so let's just conclude this one. Is a transaction. Again, keep in mind, the logic is like here. So at least one input, somebody can send all the coins out. Someone could bring it back to him or her, and the remaining would be sent to the receiver, and somebody needs to verify the message. So having said that, I identify class of crypto underline ticks. Ticks stand for transaction. I have 4 sections. First, inputs of the transaction. Who brings coin into transaction? Transaction outputs. These are the addresses that receive the cryptocurrency. My signature, the signatures of transactions, and required signatures. The required signatures refers to this. I think Dodo needs to verify. So people who verify the transactions, we need their signature. Here and there, I wait 1 or 2 minutes in case you guys need to add some comments. So do you guys have heard of the Turing Complete? So Turing Complete, if I'm not wrong, you heard about that? Okay, so Turing Complete, if I'm not wrong, just means you should loop in the codes. Turing is basically is a Nobel Prize for computer science. Turing Complete, if I'm not wrong, just means you need to have a loop in your codes, something like that, right? I'm not sure. So yeah, Turing Complete means you should have a loop in your codes or in your program. I mean, let's say in Python is a Turing Complete because you can have a loop. But in Bitcoin blockchain, you don't have a loop. So it's not Turing Complete. It's just extra information. Okay, so we have 4 section of data. Inputs is a list of tuples. So as you see, for input, the people brings crypto into transaction. We have their address and amount of coin. For output section, we have address and amount of money. For required signature, is basically people who needs to verify a message. So we also record their signatures. Okay, I think validation might be a little complicated here, but basically,
I'm just checking some, I just put some methods of verification. The first one, maybe I put it here at the last. Total in, the amount of money that comes to a transaction should be less than total out. So you might ask why they are not equal. Basically, you might send some of your input money to miners. So sometimes, which is most of the time, the total input of coins might be less than total outputs. The other thing I'm checking, it shouldn't have we shouldn't have a negative number. So amount shouldn't be less than 0. And also all the signatures should be in the signature list. So the signatures, what are the necessary signatures? The people who brings money should sign, and the people who verify should sign too. Maybe it's better I shouldn't go too much in details, but anyway, so we are checking for a few things here. First, total input of coins should be less or equal total output. We cannot have a negative coins in our transaction. Doesn't make somebody send -2 coins to someone. Also, we should have all the signatures. Those signatures are either people who require to sign, maybe miners, and also people who brings money into a transaction. Okay, so let's look at the name underline main. So as you see, I created 5 sets of public and private keys. Every time I run key generator, and the key generator just create a pair of random public and private key. I already 5 times. I have 5 public and private keys. Also, you see, it's not just key signature. It says signature.key generator. The reason I already have signature basics one, we just reviewed, is key generator, sign, and also verification. I need the key generator function from that file. So as you see here, I'm importing that file, importing signature underline basics one as signature. And here, signatures.key generator. I'm using the key generator from that signature file. I wait like a couple of minutes in case you have questions or you want to add some comments, then I go to the next part. Okay, let's look at the transactions that I have. First, I define a transaction, TX1. So from public key 1, we input 1.5 coin. From public key 3, we import 0.5. The first output is we send it to public key 2, 1.4 coins, and last output 0.6 coin to address public key 4. And public key 5 is somebody who should verify transaction. As you see at the bottom, I'm adding transaction signature from private key 3 because it's one of the inputs from private from key 3. And I add the signature for key 1 because also key 1 brings money. And also I'm adding signature from key 5 because key 5 needs to verify, the user number 5 needs to verify the transaction. Everything is correct here. Total in is 2, total out is 2. They're equal. Also, key 5 should verify, which we already added. So transaction 1 is correct. There's nothing wrong with that. Look at the second transaction. In the second transaction, public key 1 brings 2 coins. It was sent to public key 2 and 3. Input and output is equal. We don't need any extra people to verify this transaction. So we just add the signature from public key 1, the person who brings money. In essence, this transaction should be corrected. Let's look at transaction 3. So public key 1 brings 1.2 coin, public key 3 brings 1.2 coin, public key 1 brings 1.1 coin, and key 4 needs to verify. 3 is somebody who brings money, 4 is somebody who needs to verify, so I add their signature too. Having said that, number 3 is correct too, so when I do a loop through transaction 1, 2, 3, if command is true, so the first line after if command would be run. So it's the reason here you see success, the transaction is valid. All of this means all of that. Let's look at transaction 4. So transaction 4 is signed. So key 1 input 5, key 2 take the 5. The signature is from public key 2. We don't need signature from public private key 2 because the input comes from key 1. This signature is required, but we don't have it here. So this transaction is wrong because key 1 hasn't signed. Let's look at the next transaction. So I don't go to too much details, but as you see, we need a request signature of key 4. Well, we didn't add the signature here. We just add signature for private key 3. So this transaction is wrong too, because the person who must verify is not there. In the next transaction, both key 3 and key 4 brings money,
But when we add the signature, we just add signature for 3. Number 4 is not added. So this transaction is not valid too, because we don't have all the transactions that are required. So the next part of transactions, can I tell you if this transaction that I highlighted below is correct or not, and why? So if you see, input is 3, but we have two outputs of 2 and 6. So the output is 8, input is 3. Output cannot be more than input. So this is a wrong transaction. What about the next transaction? Do you think this is a right transaction, or is it correct, or is it a right transaction? Why? Yeah, it shouldn't be negative. So we can have a negative transaction, a negative value. Okay, let's look at the last transaction. So in the last transaction, after input and output, we changed one of the outputs. So somebody hack and change some of the value of the transaction output. So when you do hashing, the hash should be different from previous to like the next block. So distance is going to be verified because the transaction is modified after the transaction has happened. Okay, I think coding was a little boring for today. For the last part of the code, I skipped through a lot because I think might be too much for a two-day class. In case you have issues for understanding the last code which is transaction basis 1, please just reach me out. Especially, I think for the validation, I skipped a lot because it might be a little bit challenging. But basically, so let me just put a little more details. So for the validation of each transaction, first we call it data catcher. This is the function that catches all of the inputs, outputs, and records signature. So when we put 2 underlines before a name, just means it's an internal method and you cannot call it out of this class. Anyway, it's not important. So look at the first loop. It's a looping of address as amount inside transaction input. As long as I can find a signature that validates that input, it would be true. Otherwise, false. So just look for a signature and basically address that match. Whenever they match, it would say, okay, at least I found a signature that can validate my inputs. So it gives correct. Then another check is having negative value, which you don't want to have negative values.
Also, it checks for signature validation. So because we have some required signature, it just look through all of the signature that is is gathered through data catcher. Whenever it finds a signature that is among those required signature, it would say matches true. So it could match one signature with one of those required signature. And the last one, total output, should be more than total in, because sometimes you send some of your input for a miner as a Coinbase, as a fee, arbitrary fee, to incentivize the miners to put your information inside the block. Anyway, that was for today. Sorry, it was a little boring, but I think it was necessary. Again, some of you might have much more knowledge in Python, so his code might make much more sense. In case you have questions, please reach me later on, so I can go line by line and just explain more details. Anyway, that was for today. So we also have one more class of blockchain program with Python, but after that, hopefully class would be more interesting. Any questions? Okay, so if there's no question, that's for today. Thank you very much. Please submit your assignment. Also, either this week or early next week, please find your final project topic, because this is a very short semester. In 2 or 3 weeks, you should submit your final project. Thank you very much.